Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. High above the Earth, inside towering clouds, a microscopic drama unfolds that completely alters our understanding of physics, weather, and life itself. We typically think of cloud formation and rain as purely physical processes governed strictly by humidity, pressure, and temperature. However, atmospheric scientists have uncovered an extraordinary reality. Microscopic living organisms are actively manipulating the atmosphere. At the heart of this phenomenon lies a fundamental concept in physics known as a phase transition, the shift of matter from a gas or liquid into a solid state. Surprisingly, pure liquid water hovering high in the sky does not freeze as easily as you might expect. In clean atmospheric conditions, pristine liquid water droplets can remain fluid far below the standard freezing point of 0 degrees Celsius. This stable liquid state below freezing is known as supercooled water. Without an initiating nucleus to trigger crystallization, pure water droplets can remain completely liquid down to a freezing temperature of -38 degrees Celsius. To transform supercooled water into solid ice crystals, a crucial step needed to initiate rain and snow, the water requires a physical catalyst known as an ice-nucleating agent. Historically, scientists believed that inert mineral dust, sea salt, and volcanic ash were the primary drivers of this process. However, mineral dust particles are surprisingly inefficient, typically requiring atmospheric temperatures to plunge below -10 degrees Celsius before ice formation can occur. Enter biology's ultimate physical disruptor. Certain airborne bacteria, most notably Pseudomonas syringae, carry a remarkable evolutionary tool on their outer membranes: specialized ice-nucleating proteins. These biological molecules act as precision molecular templates designed specifically to manipulate the thermodynamics of liquid water. When supercooled water droplets collide with these atmospheric bacteria, water molecules make contact with a specialized protein surface. These proteins contain highly repetitive, rigid amino acid sequences arranged in a flat, periodic structure. This unique molecular architecture perfectly mirrors the geometric lattice of a hexagonal ice crystal. Instead of waiting for random thermal movement to align water molecules into a stable ice nucleus, the bacterial protein acts as a physical mold. It binds water molecules through hydrogen bonding, aligning them instantly into the exact spatial array required to form an ice lattice. By providing this physical scaffold, the bacterial protein drastically lowers the thermodynamic energy barrier required for a phase transition. Instead of needing frigid conditions near -38 degrees, these biological proteins can force water to freeze at temperatures as warm as -2 degrees Celsius. This makes atmospheric bacteria the most potent ice-nucleating agents existing in nature. Once a tiny ice seed forms on the bacterium's protein surface, it rapidly draws moisture from neighboring supercooled liquid droplets, growing into a heavy snowflake. Gravity eventually pulls the growing snowflake downward. As it falls into warmer, lower atmospheric layers, it melts and lands on the ground as liquid rainfall. Why would a microscopic bacterium evolve such a sophisticated ability to alter atmospheric physics? The answer reveals a fascinating planet-wide ecological feedback loop called the bioprecipitation cycle. Many of these bacteria originally live on the leaves of land plants. On the ground, they use these same ice-nucleating proteins to cause localized frost damage, breaking plant cells to feed on the escaping nutrients. Strong wind currents then sweep the bacteria up into the atmosphere. Up in the clouds, by forcing phase transitions and triggering storm events, the bacteria effectively ride the falling rain back down to land on new, green plant hosts. They are living weather makers, utilizing fundamental physics to travel across continents. Understanding how protein snowflakes initiate biological cloud seeding is revolutionizing climate science. As global atmospheric conditions shift, researchers are studying how these biological ice-nucleators influence cloud reflectivity and precipitation rates worldwide. By mapping the exact atomic structure of these proteins, biophysicists are even uncovering new ways to design bio-inspired materials for artificial snow production and cryopreservation. This incredible interplay between biological structures and atmospheric physics demonstrates that our atmosphere is not merely an inert chemical realm. It is a living, dynamic system where microscopic proteins dictate global weather patterns and cloud dynamics. For more incredible facts like this, don't forget to subscribe and turn on notifications.